Hey guys, so here is Module 6, Lesson 2, Math Chat. So let's do this together. So
Ready to get zany
I'm
with
going to go to
Zach?
the first dot. You might want to listen to what he has to say. And if we look at this, they're just talking about drawing and looking at the centimeter lines. And I can't do, oh, where's the next? There it is. Huh.
Watch as
So,
I use my centimeter ruler to draw 2 centimeter lines. And then
so
I'll extend it by counting 1, 2, 3, 4, 5, 6/10 of a centimeter more. How many whole centimeters did I just draw?
how many did he just draw? He drew 2 true holes. How many centimeters? So 2 holes plus another 6.
We drew 2 whole centimeters and 6/10 of a centimeter more.
Exactly. So we can write that as 2 centimeters plus 6/10 centimeters. Keep going.
So we're going to write that as a mixed number, 2 and 6/10.
2 plus 6/10 is 2 and 6/10. We can write that using decimals, like this.
Correct.
So both of
We
these
can
mean the
represent
same
both of
thing.
these numbers either in fraction form or in decimal form, but they still mean the same thing. Now let's break down 2 and 6/10 another way using a number bond.
So what can we break down 6/10 into? How many ones are in 2 and 6/10? 2. How many tenths are there? There are 6/10. So we need to shade in to show 2 and 6/10. So if I shade this whole thing, this is one hole. That's one of the 2 holes. Then I'm going to shade in another hole. Okay, and then I'm going to shade in 6/10. 1, 2, 3, 4, 5, 6.
Sophie, what'd you do here?
I made a number bond breaking down 2 and 6/10 into 2 ones and 6/10. Since each area model represents one hole, I shaded 2 holes completely first. Then I still had to shade 6/10. Since each of the holes are broken into tenths, I shaded 6 columns to show 6/10.
Exactly right. Our area model matches our equation. 2 ones plus 6/10. That's 2 and 6/10 altogether.
So how else do we do this? Well, we have a 2.6. So again, that's 2 holes and then 0.6.
Does our decimal number bond still match this area model?
Yeah, 2 ones and 6/10. It's written in a different form, but each part is still equivalent. So it looks the same on the area model.
Couldn't have said it better myself. How many more tenths do we need to get to 3 ones?
So if you look, how many more? 1, 2, 3, 4. Because if I add 4 more, I get a whole. So I only need 4 more, 4/10. It's not letting me. Oh, there's little boxes. 0.4. Let's keep
I
going.
looked at the area model and saw only 4/10 more have to be shaded to complete another one hole. So we need 4 more tenths to get to 3 ones.
Love it. Let's try one more on for size. I know you'll give it your all.
Let's get through this. So,
3 and 2/10.
oh, they're going to do it
That's
for us,
3
I
ones
guess.
and 2/10. First, I shaded 3 holes to show the 3 ones. And then I shaded 2 more tenths.
That's right. Now let's break down this mixed number in decimal form.
So match each fraction with its equivalent decimal form. So 3 would be 3 wholes. It's like $3, right? So that would go with 3 because it's before the dollars. 2 tenths would go with 2 tenths. And 3 2/10 would go with 3.2.
We can write 3 2/10 in decimal form like this. Then we can break it into ones and tenths. 3 plus 2/10.
How many more do I need to make a whole?
We need another 8/10 to make 4 wholes, because 2/10 plus 8/10 equals 10/10, and that makes 1 whole.
Rocked it! Nice work today representing decimal numbers with the area model. I think you're ready to take on the Tower of Power.
So hopefully that made sense, and hopefully that wasn't confusing. But let's see what Tower of Power does.